Okay, so let's look at the net ionic. So the next ionic equation, what we're going to look at, we're going to look at how to write the ionic equation from the balanced chemical equation given. So the first example we're going to look at, which one? Okay, let's say sodium chloride, which is in aqueous state, then plus silver nitrate, also in aqueous, are going to form a PPT, silver chloride, which is solid, then plus sodium nitrate in aqueous. So whenever I write in the balanced chemical equation, which will also require the ionic equation, the first thing is that you need to understand four things. Number one, the equation must be balanced. So we need to check if this equation is balanced. Then number two, we look at the compound which are in aqueous state. So this one is in aqueous, this one in aqueous, also that one in aqueous. Then apart from that, the third point is to split these which are found in aqueous. Then the one in solid, liquid, and gas, we don't split them. So after you split them, those in aqueous, then the last step is to cancel those which are found on both sides. So after we cancel them, then whatever will remain will become our net equation. So the first step we say is to balance. So we check. So we have one sodium, we have one atom of sodium, we have one atom of chlorine, we also have one atom of chlorine, one atom of silver, one atom of silver, one nitrogen, three atoms of oxygen, three atoms of oxygen. So the equation is balanced. So first step, we are done. It is balanced. Second, we split those which are in aqueous. So we have sodium. Sodium is a metal. So when it loses an electron, it becomes a positively charged. So it will be something like that. Sodium aqueous plus chlorine, a non-metal negative aqueous. So I'll split this into this. Then this plus here. Then I have silver, which is a metal, so plus aqueous. Then plus nitrate, which is a radical negative aqueous. So I've split this one and this one because they are found in aqueous. Then from here, we'll proceed. So we're going to say silver chloride, solid, because it is in solid, we can't split it. Then plus sodium, which is a metal, aqueous, and plus nitrate, which is an aqueous. You put a negative. So these charges we are putting, they are showing that you're writing ionic equation. Don't just split without putting them. Then I'm going to counter check what is found on this side and on this side. Then we cancel them. So we see that here you have sodium, here you have sodium, so you cancel it. So sodium and sodium, these are spectator ions that are not taking part in a chemical reaction. Then also have what it goes chlorine, no? This one, it is only found here, but here it is not. So this one you cannot split it. So what else? What else can we see? We have so we have nitrate, we also have nitrate here. So this and this can cancel. So what else can we cancel? I think those are the two we can cancel. So then what do we remain with? So we have these two. So I'm going to say now silver in aqueous plus chlorine, also in aqueous. So these two. then what are they forming? They are forming silver. Alright. So that is how we write the ionic equation. That is how we write the ionic equation. So that is it. So this and this, they are cancelling each other to form what equal 0. It's like -1 plus 1 is equal to 0. So no wonder this salt is neutral, because the charges have cancelled. So basically that is how we do when writing the chemical ionic equation. Then let's look for another example maybe. Now it is not always that you're going to be given an equation which is well balanced like this. Sometimes you will find that other equations are not balanced, so it's you to balance that equation. Okay, so we look at this one. Where we have copper sulfate, so number 2. We have copper sulfate, this is copper 2 sulfate in aqueous, then plus sodium phosphate, also in aqueous. So we have copper sulfate and sodium phosphate in aqueous to form copper phosphate. So I'm going to write like this. So this 2 is the valence for copper, then this one is solid, then plus sodium sulfate, which is in aqueous. So remember, when you're dealing with the preparation of salts under precipitation, we understand that we react soluble plus soluble to form insoluble plus soluble. So we have soluble plus soluble to form insoluble plus soluble. So this is what we call precipitation. That is precipitation. So what else? So now we need to balance the equation. We check. So we have copper 1. We also have, so copper 1, we have copper 3. So let's try to use this 3 and put it here. Okay. So we put 3 here. We are trying. So we have copper 3, then we have sulfur 3, then oxygen 12, 4 by 3. So these 3 will multiply everything. Here, here, and here. So sulfur 3, oxygen 3, so I have 12 there. Then what else? Sodium. Here we have sodium, we have 3. Here we have 2. So sodium is not balanced. So what if we interchange these numbers? This one comes here, this one comes here. So if you put 3 there, we have 6 sodium. If you put 2 here, we have 6 sodium. Okay, so this has affected phosphorus. So phosphorus we have 2 now. Then phosphorus again you have 2, because these 2 outside is multiplying everything inside. So phosphorus 2, then oxygen 8. Then 2 by 4 we also have 8. So 2 by 4, 8. Then these 3 by 4 we have 12. Sulfur 3. Then also here sulfur 3. Then so I think it's balanced. According to what I'm seeing, it's balanced. So now, because it's balanced, so the total number of atoms of oxygen now we have 12 plus 8, which is equal to 20. Then you also have 8 by 12, which is also 20. 6, we have 6, we have 3, we have 3, we have 3, Also there we have the, okay, it is balanced. Alright, so now we can do what we did at first. So what we said was we split these in aqueous. So we're going to say 3 copper 2 plus. So this is copper 2. Now, how do you determine that this is copper 2? You need to look at this. If I have copper 1 react with sulfate, I'll have something like this. Because copper 1 has a valence of 1, then sulfate has a valence of 2. So this one comes in, that one will go there. So once you see this, a number 2 here, just after copper, just know that this is copper 1. Now, for me to know that this is copper 2, it's because I know that if it has 2, it also has 2. These will cancel. They will give me this one. So that is how we determine when it comes to know the values. So copper 2 plus, then plus sulfate 2 negative, aqueous. Now remember that this is also for that one. So we'll put 3 there. Then plus 2 sodium plus. Then so let's multiply this by this, we get 6. We get 6. Then plus, so aqueous. Then plus 2 phosphate, the valence of 3 minus aqueous. So I'll split this side. Then 3 copper. So this number must come in front. Then you put 2 plus aqueous. So a metal you put a plus. A metal we put a plus. Then from here we'll say sulfate. Here you have 2, so it will come there. So 2 sulfate. Then we put also 3 minus, because 3 is its valence. So plus sodium 2 times 3, I'm going to get 6. Sodium plus, and we put 3 sulfate 2 minus. So that is how I've splitted the entire equation. Then from here, so you can see that the numbers are balancing. So as you are splitting, ensure that you balance the numbers. Because if you don't balance the numbers, the answer will be wrong. Unless if you have just mastered the answer. But here, if you're given 2 marks, if we counter check here, they are not balancing. From here, you can't give you a mark. So you cancel what is common now. You cancel what is common, you cancel whatever is split. So copper 3, sorry, I was just splitting, but the answer is correct. So here it's supposed to be copper 3, then PO4 to solid. We don't split what is in solid state. Remember that. So sodium is found here. We also see that we have sodium here. What else? So we have sulfate here. We also have sulfate here. So these 2 are out. So overall, or net equation now, the net equation here is to get what you have remained with. So here I've remained with 3 copper, 2 sulfate, aqueous, and plus 2 sulfate, 2 phosphate, 3 minus, then we will form copper 3 here, then 4, then put 2 solids. So that is my entire answer. So if you are to check, you will see that 2 times this one it is 6, 2 times this one is also 6. So it's having negative 6 plus 6, which is equal to 0. No wonder we don't have any charge there. So that is how we balance and write the net ionic equation. So if you're not clear, please let me know. But that is how we do it in a simple way. So this question normally comes when you have been asked to write preparation of salts. Then they'll ask you to write the equation for those 2 reactants you have used, especially under precipitation. Then after that, they'll ask you to write the net equation. So this is the net equation. Precipitation. Then after that, they'll ask you to write the net equation. So this is the net equation.